Okay, in this video I want to talk about some reflection rules. Some real common rules that we use in reflections is reflecting over our y-axis, reflecting over the x-axis, reflecting over the line y equals x, and reflecting over the line y equals negative x. So for this first example, we need to do a reflection over the y-axis. Here's my y-axis. I need to take this image and reflect it over. And after I do that, I got to be able to write the rule. So you've seen enough videos now that you know on a coordinate grid it's real easy to reflect something by just counting from the line of reflection to the other side. So I can quickly plot my points just by using the counting method. A prime, this is B prime, and C prime is going to be right there. Okay, so I know that this here is my new triangle. But I have to write a rule. So I got to write a rule that takes that pre-image and makes it go to the image. So with reflection rules, we always start off with the lowercase r, and we put xy in parentheses. This xy here in parentheses, this means for every coordinate point that's on these images. So that means for every one of these points here on this pre-image, I can apply the rule. Not just the vertice points, but every point along all the lines. Well, what happens here when we reflect that? If you notice, all the y coordinate values, they all stay the same. They didn't change any. The values that did change were the x values. So if I'm looking at point A, you notice that the coordinate point was 2, 2 in the pre-image. Well, in the image, it ended up being negative 2, 2. So what happened here? What happened was the x values became the opposite. So in rule writing, to show opposite, we use the negative sign. So I'm going to state that my x values from the pre-image to the image become the opposite. Okay? And then, as we stated before, the y values, they ended up staying the same. So they don't change. So my rule for a reflection across the y-axis is simply little r, parenthesis, xy, close the parenthesis, use my arrow, because that stands for a transformation has occurred. That arrow is critical. And then parenthesis, negative x, or opposite x, comma y, and close the parenthesis. There is the rule for reflecting across the y-axis. So now let's take a look at what happens when we reflect across the x-axis. So obviously after doing the y, the x should go a little bit quicker because here is the x-axis. And so if we take a look at our image, we can quickly reflect that image by using the counting method. So I get all my points there, construct my image. So here's my image. Now I need to be able to write a rule. Same thing. It's a reflection of the xy. Makes a transformation. And what's happening here? Which values change? Did the x values change? No. X values remain the same. The values that changed were the y. The y values became the opposite. Here my y value is negative 1. Up here, my y value is positive 1. Negative 1 and positive 1, those are opposites. So my y values became the opposite. And here is our reflection rule for reflecting over the x-axis. Let's take a quick look at one more. So let's say I want to reflect over a line. And in this particular example, I'm going to use the line x equals 2. So I want to reflect this image over that line. So I'm going to take this pre-image, reflect it over, get all my points of the vertices, because that makes it easier. And I think I got the point in the right spot. There we go. Okay, so I've reflected over the line x equals 2. So how do I write that rule? Well, really, it's pretty simple. We just did a reflection of the x, y transformed over the line x equals 2. So how do I know that it was a reflection? I know it was a reflection because of the little r. How do I know what I reflected over? Well, I know that by the equation x equals 2. So I know that this image was reflected over the line x equals 2. Hopefully this helps with you writing reflection rules. As always, you can reach out to me